Okay, let's do, let me see if I can find my problems. Okay, this one won't have numbers repeating. F of x is equal to 1/3, open parentheses, x minus 4, close parentheses, squared. What's the vertex? I'd go and do that without even typing it in, because you should know that. Positive 4 and 0. And then we need a of s, and that's x equals 4. We can go ahead and do that. That's the axis of symmetry. The y-intercept, we'll get in just a minute. It's going to be 0 blank. And then we'll have to see about x-intercepts. And what else do we need? Anything else? Is that it? I guess that's everything. Okay, and then the a is 1/3, and we'll talk about how to graph that. So let's go ahead. Would you rather graph it by hand, or would you rather put it on your calculator first? You want to do the calculator? Okay, when you go to y equals, you can either type, go ahead and clear that out. Now, you can type 1 divided by 3, and then put your parentheses and all that. But it's going to give you answers in decimals, which sometimes is better. But I like that alpha x key. If I use alpha x, or I think somebody's is still in alpha y equals, but you know where it is. If you do that, it really makes it look like this one. So we're going to put 1/3. Did I put a 3 or 2? That's a 3 in it. Okay. And then arrow to the right. It should come back. There it comes. And then open parentheses, x, that's a minus 4. Close your parentheses, square it, and you can hit graph. Now, x-intercept, y-intercept, we'll talk about them in just a second. I think the graph, this is a little bit hard to talk about x-intercepts, like we did on the last one. But this one, I think you'll see it better from our graph on our graph paper. I could have had you put these on the little calculator screen, but I like them better translating it to graph paper. Oh, I probably didn't go over far enough, but I think I'll be okay. I'll just extend this. So my vertex is over here at 4, 0. Now, I want to show you something that will help you. How can I go ahead and get the y-intercept? You see it? Oh, here it is right here. There it is right there. That's where it crosses the y-axis. What did we say to do to get the y-intercept? You're going to hit trace. And if you don't move your cursor, it should be the very first point that comes up. If you hit trace, is that the y-intercept? Is it? When x is 0, y is 16/3. Now, 16/3 might not be the best because you got to think about where that is. That's 5 1/3, but that's still fine. And if you count it, it's 1, 2, 3, 4, 5, and it's a little bit above the 5. So that's excellent. That will actually help you graph this because we're going to go, remember when it's 1/3, you're going to go up 1/3 over 1. So we're going to go up 1/3 and over 1. I promise you, up 1/3 will not work. I don't know if I've got time to show you, but it won't work. So we're going to go up 1/3 over 1, up 1/3 over 1. Now, I would go put that 16/3, which is 5 1/3. I would sketch that on here too. If it's there, I'd put it 1, 2, 3, 4, 5 1/3. Because look, you can actually do this. It just makes it easier to draw that left side. And then all you got to do is just make it symmetrical. And I'm going to run off the page, but you kind of get the feel for it. If you can sketch that y-intercept, it will make your graph more accurate. So the only thing I don't have is x-intercepts. Does it touch or cross the x-axis? I think it's more obvious on this one. Does it touch, does it cross the x-axis? What does it do? It touches at 4, 0. It's actually, the x-intercept is the vertex. A parabola, we call it, I've said in Algebra 2 Honors before, I haven't taught Algebra 2 regular in a long time, that's why I say, we've always said in there, it's just sitting right on the x-axis. It's just sitting there on it. It's not crossing it, it's sitting on it. There's your y-intercept, we stated that. Now see, here's a way you could check, and I could show you that up 1 over 3 won't work, because up 1 over 3 would be 1, 2, 3. It would be that point right there. Well, if you type in, let's see, that's 4. If you type in 5, 6, 7, if you do trace and hit 7, I don't know if it's going to do right or not. Yeah, it all goes all the way up to 3. Let's see, that's 4, 5, 6, 7, 1, 2, 3. Boy, I did very close. And that's another thing you can do. If you need more points to help you draw your graph, just type some in. Do a t-table. Type in 1, and 1 goes up to 3. 1, 1, 2, 3. Type in 2, and it goes up to, I can't read that. What does that say, 4/3? That's 1 and 1/3. I've actually done pretty good. You can make your own little version of a t-table by just doing the values. There is table on here, but table is, to me, hard. I've never used it because it is, you have to set it up, and it's not necessarily where you want it, and it just gives you numbers. It makes a table. It doesn't let you pick the numbers. Well, you can, but it's kind of a mess. This trace is, to me, it. Trace is the best. And so you can type some, and then you can plot them, and it can be very accurate. I didn't even think about that last block. We didn't think about it. Let's do another one real quick. Number 3. Let's do f of x is equal to negative 1/4, open parentheses, x minus 2, quantity squared, minus 1. What's the vertex? You see it? Positive 2, negative 1. What's the axis of symmetry? X equals, what's your x up here? Which one of these is the x? Ordered pair. X, Y. Which one's the x? 2. That's your axis of symmetry. It's x equal 2. It's the vertical line that goes through your vertex. The y-intercept, we'll have to graph it to see that. See, that's the other thing. When we do standard form, it's actually going to give you the y-intercept. So there's kind of good things and bad things about both of them. I will just go ahead and put 0 because there is a y-intercept. Every one of them cross it. To do the arithmetic, you would have to put 0 right there and do the arithmetic. And then what do we need? X-intercept, we don't know. And then we'll graph it. And if you want to put A equals negative 1/4. Do what, baby?
What was the x-intercept in the last one? 4, 0?
4, 0. Same as the vertex. It was right there. See, it just sat right on the x-axis. Okay. So let's graph it. And I'm going to tell y'all, the quadratic formula and factoring have all effects on this. It's like I want to tell you more and more, but then it's too much, so I just don't say it all right now. Okay, 2, negative 1. Okay, it's going to open down because it's negative. Okay, can I go ahead and do down 1/4? Okay, a little bit down 1/4 and then over 1. Now, I'm not going to connect it until I do the graph because I should be able to get that y-intercept. I can get me some more values over here if I want to make it really look nice. So go ahead and type this one in, and mine just went dead. So y equals, and I apologize to you, y equals, I would use my alpha x key again and do, I put the negative before I do alpha x. If you don't, you can put the negative 1 over the 4, and then x minus 2, and then negative 1. Okay, I already know what the y-intercept is. I'm gonna go ahead and sketch mine. Okay, it should look like this. And when you hit trace, what does it give you as the y-intercept? -2. So see, there it is. If you plot it, see how it makes your graph look prettier? Now, what about x-intercepts? Where does it cross or touch the x-axis? It doesn't, does it? Now, here's the real part, weird part. You can say none. I prefer no real x-intercepts because here's the weird part. There actually are 2 zeros every time. 2 intercepts, sometimes they're called zeros. We'll talk about that later too. But and that's what your calculator calls them. There's a way to find the x-intercepts built into this. It's in that second trace thing. And it will, if it doesn't show it crossing the x-axis, they're actually imaginary. The zeros of the x-intercepts are imaginary, and you can't draw imaginary numbers on a real axis. See, this is just real numbers both ways. So that's why a lot of times we just say they're none or no real. It's fine for me, but it doesn't cross the x-axis here. So you've got a case where you had 2, you had 1, and actually it's, remember when we factor them and it would be 4 and 4 when the numbers are the same? That's where factoring and all of this comes together. You can glue this on page 77. If you need some ACT practice, and especially as juniors +1 sophomore, there's an excellent, Dr. Phillips, Kaylee's dad, does a ACT workshop for several hours. Now, I think since COVID, he does it by Zoom on Wednesday nights for several weeks. He used to do it all day on a Saturday, but it's like $125, $150. Next Wednesday night from 8 to 9, he's going to do a free webinar, and it's just going to be math. He's going to do and he's a math person. So he's awesome. That's a great workshop. And this is just a free hour cram-packed. They call it a power session. Cram-packed with ACT math, especially if you're going to take it in February. I think that's why he's doing it right now, because the test is coming up in February. Okay, I'm going to get ready for